Another of the more interesting ways of getting fire or forming your fire egg is using a can of pop and a chocolate bar. In doing this, we take advantage of the fact that the depression that is stamped into the bottom of a can of pop is very, very close to the shape of what's called a parabola. A parabola is a shape which will take the sun's rays and reflect them and focus them at the same time to a point above the reflector. The main problem we have with a can of pop is this surface is not very reflective. The solution is found in chocolate. The cocoa powder that's found in chocolate makes an excellent polish that will take aluminum and polish that up to a mirror-like finish. It is time intensive and labor intensive. It takes about an hour of continual rubbing to take this aluminum and get a mirror-like finish. What you do is you take your chocolate and you're just going to rub the chocolate on there. If you want, you can use the wrapper to help you, or you can use your finger, and you just rub and rub and rub and rub and rub. When you're through rubbing and clean up, you should have a very highly polished surface, like the bottom of this can. Here's the can that we've polished down to get a reflective surface, a parabolic reflector to try to light things with. As you can see, the bottom of the can now has a mirror finish to it. Now the trick to this is lining up directly with the sun. If you look at the shadow on the ground, you can see how as I move the can back and forth, it gets bigger, smaller. If you minimize that, if you get a small circle, then you know that can's pointed directly at the sun. You then take your tinder and you put it at the focal point, which for this is going to be, there we go, and it's lit. Here's just a simple little exercise to help illustrate the principle of the volatiles that burn when you burn wood. If you'll take a look here at the matchstick, in a moment we're going to light it, and what you'll see is you'll see flame coming out the sides, and the size of the match will actually shrink down as the volatiles come out of the wood and turn to gas. Then as we get all the volatiles out of the wood will start to glow, and that'll be a sign that most of the volatiles are gone and the solid part of the wood itself is starting to burn. Now we're putting the thought of the volatiles to the test. If the theory is true, then as that fire burns, it should only be hot on the outside of the gas where it mixes with the oxygen, not on the inside of the gas where there is no oxygen to burn. Because I put my finger directly against the wood, there was no oxygen to mix between my finger and the wood, so it didn't burn. If I'd moved that match even a little bit away from my finger, it would have allowed oxygen to get in between my finger and the wood. The gases would have burned there, and I would have burned my finger.